Welcome to the new session of electronics. In this presentation, we are going to see some real world applications of the microcontroller 8051. I'm going to explain you how to interface the microcontroller 8051 to devices such as an LCD. Let us look at the objectives of this presentation, that is, list few reasons for considering LCD, and the next one is going to be the functions of the pins of typical LCD, command codes for programming LCD, interface an LCD to the microcontroller 8051, and the programming techniques are going to be the objectives of this presentation. As we are all aware of, alphanumeric displays are used in wide range of applications including palm tap computers, word processors, photocopiers, point of sale terminals, medical instruments, cellular phones, etc. Today we are going to see the working details of 16 by 2 LCD, which is an intelligent alphanumeric dot matrix display which is capable of displaying 224 different characters and symbols, and this number varies from one LCD to another LCD. So let us look into another introductory information, which is why we are considering LCD. Why not LED? LED is a light emitting diode. Why we are not considering that? Why we are giving importance to this LCD? So the major factor, a very important factor, is the declining prices of LCD. So cost is a very important parameter when you are considering any component in your application. We should look into this parameter also. So the declining prices of LCD is first and foremost important parameter, and the ability to display numbers, characters and graphics. So this is another very important parameter. The third very important parameter is incorporation of refreshing controller into the LCD, thereby relieving the CPU of the task of refreshing the LCD, and ease of programming for characters and graphics. So these are the main reasons why we are considering LCD, preferring LCD over LEDs. Let us look into the various types of LCDs. So various types of LEDs are 16 by 1 alphanumeric LCD, 16 by 2 alphanumeric LCD. They're available, you can see them on the screen. 32 by 2 alphanumeric LCDs, 32 columns and 2 rows. A string length of 32 can be displayed in the first row, and another string length of 32 can be displayed in the second row. Similarly, 16 by 4 alphanumeric, the next one is going to be 128 by 64 graphical LCD. So there are few LCDs which are available in the market. Apart from these, you will find varieties of LCDs which we have to select according to our requirement. Now let us look into the technical details of the LCD. It is 16 by 2 alphanumeric LCD which is of our interest. The first pin is going to be, it's a 16 pin LCD. The first pin is going to be the ground pin, 0 volts. The second pin is going to be supply voltage pin. Third pin is going to be VEE, which is a contrast adjustment, can be done through a variable resistor. Register select and reader write and enable pins are the three very important pins, which we will discuss them in the next two slides. And DB0 to DB7 are data pins, and 15th pin and 16th pin are going to be LED plus and LED minus. You can adjust the backlight intensity using this these two. The fourth pin is going to be register select pin, and the fifth pin is going to be reader write pin. Sixth pin is going to be enable pin. So what are the importance of these three pins? How are we going to use these three pins effectively in working with the LCD? We'll see in the next slide. Now, the foremost one is register select. The name itself is suggesting that we can select any register using this pin. Basically, there are two very important registers available inside the LCD. They are instruction command code register, and the other one is going to be data register. So how to select command code register and data register? So we use this pin, register select pin, to do that particular work. If we put 0 on register select pin, your intention is to give some instruction to LCD. So means instruction code, command code register is selected if register select is equals to 0. If register select is equals to 1, you are sending some data. So nothing but the data register is selected. So you can see in the waveform here, register select is 1, then it is 0, again it is 1 here. So if register select is equal to 1, your intention is to give some data. If register select is equal to 0, your intention is to give some instruction to LCD. Coming to the next one, that is reader write. Reader write. The name itself is giving an idea that maybe read, maybe write. So it's a input allows the user to write some information on the LCD and to read some information from LCD. If reader write is equal to 1, then you have to understand that we are reading from LCD. And if reader write is equal to 0, then you have to understand that we are writing something onto LCD. And the next important pin is going to be enable pin. A high to low pulse must be applied to this pin in order to latch the data present on the data pins. This pulse width must be a minimum of 450 nanoseconds wise width, right? So you can see on the screen that E means enable pin. Here it is low, low to high, and high to low pulse, high here, and then this transition is high to low. So this pulse width should be 450 nanoseconds. And there are few commands which we have to follow, which we have to give as a part of initialization of this LCD. So there are few commands. So in this table you can see code hex, means this is a hex equivalent of this instruction. 01 is a hex code, which means clear the display screen. If you want to clear the LCD screen, you just have to give a command, that is 01. If you give 02, return home. 04, decrement the cursor, means if you want to shift the cursor to the left side, you just have to give 04, right? And Like that there are few commands. So like 08 display off, cursor off, 0A display off and cursor on. Let us come to the next one. 80 force the cursor to begin to first line. If you want to display some information in the first line, you have to give a code hex as 80. If you want to start displaying the information from the fourth column, then you have to give 84. Fifth column 85, sixth column 86, like that. You can use those hex codes. Similarly, you want to start the display of information from the second row, then the code hex equivalent is C0, which is force the cursor to begin to the second line, and the last code hex are 38. The meaning of this 38 is 2 lines and 5 by 7 matrix. So the data is going to be present in the form of means each character is going to be present in the form of 5 by 7 matrix, and we are going to put the given data in 2 lines. That is what the meaning of this code hex. So what is this 5 by 7? 2 lines, 5 by 7 matrix. So this is one such a character, capital A, and this is another character, small a. Capital A is arranged in this particular boxes. So you can see the boxes. There are 1, 2, 3, 4, 5 columns, and 1, 2, 3, 4, 5, 6, 7. So means it's a 5 by 7 matrix, 5 columns and 7 rows. Okay, each character is designed in this particular matrix form. So you can design your required character according to this particular thing, right? Now this is upper case A and this is smaller lower case a, right? So now you can see here D0 to D7 is a data. Command is an 8-bit number, as well as the data or the character what you want to display on the LCD is also an 8-bit number. So D0 to D7 is an 8-bit number, maybe a data, maybe a command. So there are few steps which we have to follow in order to give a command, right? So the first thing is put the data on the data bus and then give register select is equal to 0. RS register select is equal to 0. If register select is equal to 0, you are giving a command. Then make reader write is equals to 0, because you are giving some command to LCD. So you are sending some data, you are writing some data onto LCD. So it's a write command. So reader write is equal to 0. Now after that, make enable pin is equal to high. Then with some time delay, you make the same pin equal to 0. So means set the pin and then clear the pin. Just like set B, P2.2 is used to set that particular pin, because here P2.2 is connected to in this program P2.2 is connected to that enable pin. So enable pin is made high using that instruction. And lcall delay, delay is a program, and after that, after certain amount of time delay, clear P2.2. So means that enable pin is made low. So a high to low pulse will enable the data to go into that command register. Then return. Then coming to the, so these are the 3 steps. First thing is register select is equal to 0 for the command. If register select is equal to 1, you are giving some data. So the next one is going to be read or write should be made equal to 0, then enable should be made equal to high, then low, right? So this is what is going to be the circuit diagram. You can see clearly here P1 is supplying the data. Through P1 we are supplying the data to this LCD, which is an 8-bit number. So here the first line is P1.0 is labeled as 0, P1.1 is labeled as 1, P1.2 is labeled as 2. Similarly, P1.7 is labeled as 7. So all these are connected to D0 to D7 data pins of DB0 pins, DB pins of this LCD. And you can see this register select fourth pin is connected to P2.0, read or write is connected to P2.1, enable pin is connected to P2.2. Now, so this is what is the program which is used to display single characters. Now, my intention to write this program is to display BVC. So after the execution of this program, above program, you will see BVC, Bhavans Vivekananda College, in short BVC, will be displayed on the LCD screen. Let us see how to do this particular interfacing work. Now, so initialization first. So before going to start this, org is a directive, right? Move 38. So this is we know what is meant by this 38. Initialization of LCD, 2 lines 5/7 matrix. Put that 38 in A accumulator and call the command write subroutine. So we will discuss about this command write subroutine later. In this main program, we are going to use 3 subroutines. The first one is going to be command write, the next one is going to be delay, and the next one is going to be data write. Okay, and P1.0 to P1.7 are connected to LCD. As I already have shown you that P1 is supplying the data, and P2.0 is connected to register select of LCD, right? Now P1.1 is connected to read or write of LCD, and P2.2 is connected to enable pin of LCD. So now, so 38 is a command code, 0E is a command code, and 01 is a command code, 06 is a command code, 84 is a command code. So all these command codes one after the other. So like after 38 we are giving 0E, after the 0E we are giving 01, after 01 we are giving 06, after 06 we are giving 84. So but with 2 instructions in between. The first one is going to be, as this is a 38 is a command code. Okay, when you are giving a command code, we are calling a command write subroutine, and after this subroutine we are writing a delay subroutine, because it should be, there should be some amount of time given to LCD to switch from one command to another command, to take one command after the previous command. So this is the time delay between 2 successive commands, right? So similarly you can see lcall command write, lcall delay. Move A, and then 01 is a command, clear LCD command, and then lcall command write, lcall delay. Then 06 is another command, command write and delay, right? So after that, after all the commands are given, you give the first character and then call another subroutine called as data write. When you are giving the data, you call a subroutine called as data write, right? So now give the first character, call the subroutine and call the delay. Next character, call the subroutine, call the delay. Third character, call the subroutine, data write and call the delay. So all these instructions should be repeated. So once only. If you put this again here, S jump, short jump, back here. So if you put this again here, so what happens is So there will be a repeated display of BVC continuously on the screen. But now if this is labeled, if this particular location is labeled as again, it will display BVC and stop 1. Now the subroutines. In the main program, we have come across three varieties of subroutines. The first one is the delay subroutine. Obviously, the name itself is telling that there will be some time delay generated after the execution of this program. So, delay subroutine is used to get some time delay for our requirement. So, data write is another subroutine. Command write is another subroutine. If you are giving some command to LCD, so these set of instructions will be executed. So these set of instructions are very simple. The first step is going to be, if you are giving command, or we are all aware that command means register select should be made equal to 0. So as P2.2 is connected, P2.0 is connected to register select, that is first made equal to 0, then read or write is equal to 0, enable pin must be made equal to high, then to low. So then return to the main program, right? Then coming to the next one, if you are giving some character, so just like B, V, C, which is data. B is the first character which you want to display. So after giving the data, you have to call a subroutine called as data write. So what is there in this data write? Right. So now data write is a subroutine. So in that the first step is going to be register select pin should be made equal to 1. We are all aware of this point. When you are sending some data to the register select data, when you are sending some data, register select should be made equal to 1. When you are giving some command, register select should be made equal to 0. So that is going to be the first step. Register select is made equal to 1, then read or write is equal to 0, then enable pin is made high, then to low, and then return back to the main program. Okay, so these are the three subroutines which will help us in writing the same set of instructions a number of times. The first one is going to be delay program. Whenever there is a need of delay, we call this delay program. And then data write. When you are giving some data, instead of writing these instructions repeatedly, we call this subroutine. When you are giving some command, we call this command write subroutine instead of writing these instructions repeatedly. So this is what is these are the subroutines, and this is the programming technique. The next one, so after the execution of, in the next slide you can see on the slide that this P1 port 1 is connected to the data pins, register select is connected to P2.0, read or write is connected to P2.1, enable pin is connected to P2.2. So upon the execution of the above program, you will see BVC coming on the LCD screen. So in order to display some string like BVC, do we have to write such a lengthy program? No need. So if you adopt another method, so you can reduce the code complexity to a greater extent. So this is how we can reduce the code complexity. So that is, in this slide you can see sending the information to LCD using MOVC instruction. So we are going to adopt another method of reducing the code complexity. So we are placing all the commands from one memory location onwards, a string whatever we want to display on the LCD in one particular memory location onwards. We are using DB directive. 38 is the first command, 0 is the next command, 01 is the next command, 06 is the next command, 84 is the command, and 0 is for programming, to identify that this is the last command, we are giving 0. Similarly, hello, I want to display hello on the LCD screen, so I placed this hello string in one particular memory location onwards. So this is the main program. The slight modification in the previous program, it's like we are using move data pointer. So data pointer is initialized with this starting address, so it is referring to this location's starting location. So A is cleared, and then it is uh, as this 38 is a first command, so we are using the same command command write subroutine and delay subroutine here. There is no changes in these two subroutines. Okay, so now first 38 will be given, then 0e will be given, then 01 will be given, 06 will be given. So now Z84 will be given. Jump on 0, send data. Jump on 0, send data. Right? If this number is not 0, you it will treat that as the command. So it will not come out from the loop. The cursor will not come out from the loop. So jump on 0, as the last character is 0, so jump on 0. Yes, the last character is 0, the number is 0, so it will come out from the loop, right? So and then go to the next data. Now here data pointer is initialized with the starting address of this particular starting character. Okay, so then one character after the other will be displayed on the LCD screen by using subroutines called data write and then delay program, right? So to move from first character to next character, we are incrementing the data pointer and then bringing that character and giving it to this subroutine, then calling it time delay, then again going to the next character, then next character, then next, like that. So till we reach the last thing, that is 0, jump on 0. If the last data is not 0, it will continue displaying, continue sending the data to the LCD. If the last character is 0, it will stop sending the data to LCD. It will come out from the loop, and then it will repeat that process of displaying hello hello continuously on the LCD screen. So this is how we can reduce the complexity, code complexity, in displaying a string. Okay, so now here you can see the output. So port 1 is connected to data pins, register select is connected to P2.0, P2.1 is connected to read or write, enable pin is connected to P2.2. So now the moment I execute this particular program, you will see a hello, a string coming on the LCD screen. Okay, so this is going to be the last slide of our presentation. So the outcomes of this presentations are, I believe that we have learned how to interface real world devices such as LCD to the microcontroller. We described the operation modes of LCD and how to program the LCD by sending data or command to it via its interfacing to the 8051 microcontroller. We got an idea how to work with alphanumeric LCD. This knowledge will help us in understanding the interfacing methods of other LCDs which are available in the market by just having a look at the data sheets. Okay, so in preparing this presentation, I have used few simulators. Simulators used in this presentations are Proteus 8 Professional and Microvision Keel 3. So these are the simulators which helped me in bringing out this outputs like this.